Did you know that one of the fastest Lamborghinis ever built is powered by an idea that didn't start in a factory, or in some boardroom full of investors, or even on a racetrack, but with a simple sketch drawn in pencil? In a quiet Oxford lab, a young man named Tim Woolmer was obsessed with something most people found boring: electric motors. Back then, it wasn't about speed or horsepower. It was about solving a problem nobody else was tackling. Traditional motors were heavy, crammed with iron that didn't actually add power, just dead weight. Woolmer was convinced there was another way, and he found it. By 2009, he had founded a company called Yasa, short for Yokeless and Segmented Armature. While other startups were chasing batteries or apps, Woolmer zeroed in on torque. Quietly, Yasa built a motor that flipped the equation upside down. And car makers noticed. Ferrari put it to work. Koenigsegg took it further, and Lamborghini has now gone all in. But what's really fascinating isn't who's using it, it's why. Because this isn't just a shiny new piece of hardware, it's a new way of thinking about turning electricity into motion. Magnetic magic, the axial flux secret. At the core, every electric motor is nothing more than a dance between magnets and electricity. One part spins, the other stays still, and the magnetic field in between forces everything into motion. But not all motors dance the same. Most EVs today use radial flux motors. In these, the magnetic field flows outward from the center, like the spokes of a wheel. It works, it's reliable, but it's not the only way. Woolmer focused instead on axial flux, where the magnetic field flows sideways along the motor's axis. Imagine two spinning plates facing each other with magnetic energy pulling between them like invisible glue. So why does this matter? It's about leverage. The farther from the center the magnetic force is applied, the more torque you can generate for the same weight, like using a longer wrench to loosen a stubborn bolt. Axial motors take advantage of this, delivering massive torque density. But there's a problem. Push components further out and stress levels skyrocket, making high-speed spinning harder and riskier. Most designs hit that wall and stopped, but Yasa didn't. Yokeless and Segmented, a radical redesign. Yasa isn't just a clever name, it's the whole blueprint: Yokeless and Segmented Armature. 3 words that quietly rip up decades of engineering tradition. In a normal motor, the yoke is a thick iron shell that holds everything together, channels magnetic fields, and adds structural strength. But it also adds a lot of weight. Woolmer made a bold decision. He ripped it out entirely. Instead of a heavy iron ring, Yasa uses a lighter custom structure reinforced with advanced materials that keep the motor rigid without disturbing the flow of magnetism. Then comes the segmented armature. The copper windings, the coils that carry electricity, aren't one solid block. They're broken into individual segments. That simple shift opened up pathways for air and coolant to flow directly around the coils, massively improving thermal management. The result: less iron, better cooling, and a far more efficient use of magnetic energy. To most engineers, this looked reckless, even fragile, but Woolmer proved it could work. And once the weight started melting away, everything else started changing too. Engineering elegance. Every coil counts. Electric motors are judged by how they use the energy we feed them, and most of them waste far more than they should, especially in their copper windings. In a typical radial motor, long stretches of copper extend outside the magnetic field. These end windings don't do any work. They just sit there heating up, dragging efficiency down. It's a design flaw baked into nearly every drivetrain on the road. Yasa's axial layout flips that weakness on its head. The magnetic field presses directly across the face of the copper coils, and because of the segmented structure, nearly every millimeter of copper is positioned inside the sweet spot of magnetic force. No wasted sections, no dead zones. Even better, coolant slips right between the coils, meaning the motor can hold high power longer, regulate its temperature, and avoid choking when pushed to the limit. Suddenly, it wasn't just about torque anymore. It was about control, about packaging energy tighter, about making every gram, every strand of wire pull its weight. That's the elegance that makes the Yasa motor a true breakthrough. Lamborghini's Revuelto is a triple threat. Lamborghini didn't just buy a motor, they redesigned an entire powertrain around it. Their new supercar carries 3 of these axial flux motors, each one strategically placed for maximum effect. 2 sit on the front axle, enabling torque vectoring, where each wheel receives a customized flow of torque in real time. That lets the car slice through corners with a balance and precision no human driver could ever achieve alone. But the real marvel is the third motor. It's built directly into the V8 engine housing, not beside it, not tacked on after the fact, but embedded between the combustion engine and the dual-clutch transmission. No clutch, no lag, just instant power. At low speeds, it fills the gaps where turbos stumble. At high speeds, it keeps everything synchronized in seamless harmony. It doesn't just add horsepower, it changes how the car feels. Smooth, immediate, alive. And because it doubles as both a starter motor and a generator, it simplifies the entire system. 3 motors, 1 philosophy. Integrated not for complexity, but for clarity. Numbers that break the rules. Each Yasa motor in the Revuelto weighs only 17.3 kilograms and measures just 70 millimeters thick, backpack size. But don't be fooled, each produces 110 kilowatts, about 148 horsepower. Combine all 3, and you're looking at more than 440 horsepower, coming from units small enough to carry under your arm. And all of this is powered by a 3.8 kilowatt-hour battery pack, tiny compared to what you'd find in most EVs. That's proof the efficiency isn't just marketing. It's real, usable, repeatable. Stack it up against the best radial motors out there, like Lucid's. Sure, they can match on peak power, but torque density, packaging, not even close. Yasa didn't just build a motor. They built something that challenges what a performance car even is. These aren't numbers for spec sheets. They're numbers you can feel in speed, in control, in the raw experience of driving. And that's what makes them dangerous, in the best possible way. Beyond cars, a template for the future. The Yasa story doesn't stop at Lamborghini, because once you prove that axial flux motors can be mass-produced reliably and affordably, you open the door to entire new industries. Electric planes, motorcycles, farm equipment, robotics, even spacecraft. All of them need compact, torque-dense motors with better cooling. All of them benefit from this design. For decades, axial flux was considered exotic, fragile, too complex for volume production. But Yasa shattered that myth. And with that breakthrough, they've drawn up a new template. One where torque doesn't demand bulk, and power doesn't come with trade-offs. If the auto industry follows, EVs could shrink their batteries, ditch complex transmissions, and free up space. It's not just luxury, it's smarter engineering. And when technology like this hits the mainstream, it doesn't just improve machines, it redefines what we expect from them. Where ideas become power. What makes the Yasa motor special isn't one component, it's the balance of all of them. The yokeless frame, the segmented coils, the magnetic alignment, the cooling channels, every part pulling its weight. That's rare in engineering. Innovation usually comes with compromises. Here it comes with harmony. What started as a quiet idea now powers one of the most advanced Lamborghinis on the planet. And it won't stop there. Lamborghini is only the beginning. More automakers are already paying attention. Yasa is scaling up, refining, and preparing for true mass production. This isn't a prototype. It's a product, a platform, and a signpost of where the future is heading.